Good morning, all of you. Good morning, all my dear students. Good morning. Welcome to Unacademy. Let me start the session with my introduction. Myself, Venkata Krishna. My qualification is MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience across the country in training the students in 3 different subjects: design and analysis of algorithms, the core subject for CSE students; engineering mathematics for all engineering students; discrete maths again for computer science and engineering students. I welcome you all to Unacademy. Unacademy is the best online platform in India for all competitive examinations like GATE, engineering service examinations, IIT joint entrance examination, mains, advanced, UPSC, civil services, etc. etc. If you are an aspirant of any competitive examination, you can safely take a subscription in Unacademy. Now let's see what type of subscriptions are available in Unacademy. Here one you can find with the plus symbol, another you can find with the star symbol. This is Unacademy Plus subscription. This is Unacademy Iconic subscription. Sir, what are the benefits of Unacademy Plus subscription? Right, see, interactive live classes, test series, scheduling will be in a very structured manner, unlimited practice in the form DPP, daily practicing problems, free products, free quizzes, etc. etc. So these are various benefits of Plus subscription. Now what about Iconic? Iconic is extension of Plus subscription. So whatever the benefits are there in Plus subscription, they will be extended to Iconic also. In addition to these features, Iconic will have some more benefits. One is personal coach. Once you take a subscription in Iconic, within few hours one personal coach will be appointed to you. So he or she will take care of you, everything about your academics or GATE plannings, etc. Study planner will be there. You will get guidelines from experts of subjects. It contains questions and answers of engineering service examination mains. I am telling you very seriously, if you are a genuine aspirant of GATE or engineering service examinations, better to take subscription either in Plus or in Iconic today itself. Don't be late. Hurry up, students. Now, in case of Unacademy Plus, 1 month duration subscription is available. 3 months, 6 months, 1 year, 1.5 year, 2 years. But if you want to be in more safe zone, at least you prefer 1 year subscription. Now this is related to 1 year. It is 1.5 year. This is for 2 years. In all the boxes, you can find GVK10. This is my referral code, promo code. If you use this referral code when you are taking subscription, you will get 10% discount. Now, in case of 1 year, the fee structures are like this. In case of 1.5 year, 34,650. In case of 2 years, it was 39,600. Even EMI facility is available. Now, in case of Iconic, 1 year subscription, 2 year subscriptions only available. There is no 6 month subscription. So, in case of 1 year, 45,225 is fee structure. In case of 2 years, 66,600 after using my referral code. Remember, students, you do not have EMI facility in case of 3 months and 6 months duration. So, in this slide, I am going to explain you how to install Unacademy Learning app, how to access a free products like quiz, special classes, etc. Type Unacademy Learning app in your Play Store, install it, it will be installed. So you can find multiple options. Get subscription option is visible, go through that. You can find view plans box. So it will ask referral code. You type GVK10. So from that moment onwards, it takes maximum 2 to 3 minutes. So you can become active subscriber of this. Now these are various plus batches handling by best educators of AAA and ECE. Now this is Unacademy GATE English January month schedule. So I am taking foundation course for GATE 2022, Monday to Friday, every day 5 p.m. to 6 p.m. students, along with many initiatives have been taken by Unacademy English GATE English channel. Hurry up, students. Right. Now let us start the session with a new concept, that is complex variables. Good morning, Vijay. Good morning, Mahesh. Good morning, Gayatri. Good morning, Jagdish. What is your doubt, Jagdish? When digital electronics will start in our channel? Okay, that electronics people have to say. I belong to computer science and mathematics, right? Okay, right. So yesterday we have completed probability and statistics part. So few problems, if some problems are pending at all, I can discuss those questions in special classes also. Okay. Now let us start the last concept, that is complex variables. Very, very important session, students. And if you follow theoretical concepts, you can easily crack complex variables. Right. First of all, let us see. I will discuss orally. Suppose I have a number like this, a plus ib, b, a plus ib. So a is a real number, b is a real number, and I is an imaginary number whose square is -1. In that case, such number is called a complex number. So basically, complex numbers are denoted by this z. So I have a notation z equal to a plus ib. So this is a complex number. So complex variable is denoted by the variable z equal to a plus ib. Now here you can look at this. Here I is a symbol whose square is -1. I is a symbol whose square is -1. Now in this case, there are two real numbers involved. One is a, another is b. Here a is nothing but a real part of z. B is associated with I. So b is imaginary part. So here a is nothing but real part of z. So therefore, in this case, I can have short form notation, that is RE of z. So real part of z is a. Here b is nothing but imaginary part of z. So this is imaginary part of z. So I can have the notations like this. Im of z equal to b. Im of z equal to b. So whenever a number is taken in the form z equal to a plus ib, where a and b are real numbers and I square equal to -1, such numbers are called complex numbers. The variable I'm using to represent a complex number is z, that is complex variable. So here a is real part of z, b is imaginary part of z. I can have these notations. Even I can represent this number as a point-wise notation. If I want to discuss the geometrical properties of complex variables, this is equivalent to a two-dimensional point. This is equivalent to a two-dimensional point. Now, I am going to discuss what is the modulus of a complex number, what are its properties, what is complex conjugate, what are its properties, what is it, how a circle looks like in complex variable, because circle plays very, very important role in the contour integration process. Let me tell you more clearly what type of questions you can expect in complex variables. Let me tell you what type of questions you can expect in complex variables. So if you belong to mechanical stream, every year they are asking one question based on Cauchy-Riemann equations. So if you want to analyze Cauchy-Riemann equations, if you want to understand Cauchy-Riemann equations in a very simple manner, you should have basics on differentiation, continuity. That's it. Already we have seen differentiation, differentiable properties, continuous properties in the differential calculus of calculus part. So I don't think so there are issues. Even we have residues and poles. So for residues or poles, I need to have series expansions. So we have seen Taylor series expansion, Maclaurin series expansion in case of differential calculus. So therefore, residues and poles are very, very important. They play a vital role in the analysis of contour integration. So circle plays very, very important role, and geometrical properties of complex numbers can be analyzed by using this point-wise notation. Even bilinear transformation concept is there. So if you Cauchy residue theorem, Cauchy's integral formula, etc., etc. Okay. Okay. Yeah, Revati Tadepalli. Okay, it's okay. No issues. It's okay, Revati. No problem. Attend your college class also. You can follow my class in recorded mode later. Don't worry. Right. So therefore, Cauchy-Riemann equations are this is very important concept. In simple also, bilinear transformation, contour integration, residues, poles, Lorentz series expansions. So I can finish this by this Saturday, January 9th. Don't worry, students. Now look at this. This is point-wise notation. Now, suppose I have z equal to a plus ib is a complex number. Now, its modulus is nothing but square root of a square plus b square. So, this is nothing but modulus of z. Modulus of a complex variable z. Now, let me take complex conjugate z bar. This I can represent it as A minus IB. This I can represent it as A minus IB. So this is what's our complex conjugate. Now point number 3. This is argument of Z. So this is an angle theta, which is given by a simple mathematical equation, that is a tan inverse of B by A. So this is nothing but argument of a complex variable. This is argument of Z, that is nothing but theta, which is nothing but tan inverse of B by A. So modulus have been discussed, complex conjugate have been discussed, even argument of Z. So let me tell you few formulae related to modulus, complex conjugate, as well as argument of this. Okay. So few important points. Suppose I have two complex numbers Z1 and Z2. Apply addition between them. So Z1 is one complex number, Z2 is another complex number. Apply addition, you will get new complex number. So I have eligibility to talk its modulus. This is given by less than or equal to mod Z1 plus mod Z2. Now this is nothing but a triangle inequality. This is a triangle inequality. Suppose if I have dot symbol between them, modulus of Z1 times Z2 equal to modulus of Z1 times modulus of Z2. Now take the ratio, modulus of Z1 divided by Z2. So this is nothing but mod Z1 whole divided by 2. Of course, Z2 should not be 0. That is clear. These two properties are called linear properties. These are linear properties. Now let me go through this complex conjugate. Suppose I have Z1 plus Z2. Apply complex conjugate. Even I can have minus also here. So apply plus or minus between two complex numbers Z1 and Z2. Apply conjugate. So you will get like this modulus, complex conjugate Z1 plus. If it is plus, you will get plus. If it is minus, you get minus Z bar. Even this also comes under linear property. So here apply product Z1 into Z2 whole bar. This is Z1 bar times Z2 bar. Even you can take ratio also. So Z1 by Z2 whole bar. This is nothing but Z1 bar whole divided by Z2 whole bar. Z1 bar whole divided by Z2 whole bar. Of course, the denominator should not be 0. Now let me discuss two important points which are connected to argument of product of two complex number, which is nothing but argument of ratio of two complex numbers. So these are very, very important, sir. Argument of Z1 times Z2. So this is given nothing but argument of Z1. This dot should be replaced by plus. This is argument of Z1 plus argument of Z2. Now let us take the ratio function and apply argument. So argument of Z1 by Z2. This is argument of Z1 minus argument of Z2. If you look at closely point number 6 and point number 7, they resemble log function. Log of AB equal to, you can look at this in a simple manner. I am writing log AB equal to log A plus log B. Am I right? So when you apply a log the function for ratio of two numbers, log of A by B is nothing but log A minus log B. So the argument function is behaving just like a log function. At least for these two rules. So we are not sure that whether it is exactly equal to log. That's a different issue. But argument function behaves just like a log function in case of product of two complex numbers, in case of ratio of two complex numbers. Hope it is clear, students. Right. Now I will discuss circle. This plays very, very important role in the analysis of contour integration. Basically, how to define a circle? You might have gone through circle concept in your +2 level. So circle will be described by two important parameters. So one is a center, another is a radius. One is a center, another is a radius. Suppose I am starting with a fixed point 2, 3. I am starting with a fixed point 2 comma 3, say for example. So I want to consider all points which are at a distance of 6 units from this 2.2 comma 3. So consider all points which are at a distance of 6 centimeters or 6 units from this point. So multiple points will be there. So like this I am plotting using these dots, multiple points. So you add all these points, you get a circle. So therefore this is nothing but a locus, the concept of locus. So therefore all these dots, what all these dots, infinitely many dots will be there. So all these dots represent a 2D points which are at a distance of 6 centimeters from this fixed point 2 comma 3. You start with any fixed point, you start with any fixed distance. You consider all points which are at a distance of this 6 centimeters from this fixed point 2 comma 3. Join all these. You will get one closed curve that we call it as a circle, and that fixed point is called center and the fixed distance is called a radius. So generally we can represent like this. X square plus y square equal to a square. In this case my center becomes origin, C stands for center, or for radius it is a. Now in case of general center, general radius, I can have like this. So I may have like this: x minus h whole square plus y minus k whole square equal to r square. So here center is h comma k, radius equal to r. Center equal to h comma k, radius equal to r. Now I am defining circle in the complex variable. Suppose I have an equation in this form. An equation of the form modulus of z minus a equal to r is called a circle. Having center at a comma 0 and radius this smaller. So whenever you take a number, an equation modulus of z minus a equal to r, that is called a circle having center at a comma 0 and radius r. Z is a complex variable, so z can be replaced by x plus iy. Let me do this in the next page. So I have modulus of z minus a equal to r. So replace z by x plus iy. So modulus of x plus iy minus a equal to r. So here I can group these real parts as well as imaginary parts like this. Now apply modulus. So this becomes square root of x minus a whole square plus y square equal to r. So now apply squaring on both sides. You will get x minus a whole square plus y minus 0 whole square equal to r square. So that's why here center, C stands for center. Center equal to a comma 0, radius is capital R. In this case it becomes smaller. In this case it is smaller. Now it is very clear, students. So center becomes a comma 0, radius is r. Center is a comma 0 and radius is r. It's clear, right? Now we will see when points will be called as interior points, when points will be called as exterior points. So I am going to discuss two important definitions. Attention please. Interior point. Suppose I have a complex number z0. I have a circle C. So when do you say that like this? Interior point. If a point lies on the boundary of the circle, or if a point strictly lies inside the circle, in both the cases it will be called as an interior point. I am drawing circle object here. This is some circle. Suppose assume that this is my point P or this is point Q. In that case both P comma Q are interior points. Here both P comma Q are interior points. Here P is a point which is exactly lying on the boundary of the circle. Q is a point which is strictly lying inside the circle. So how to represent these points mathematically? I am coming to that point. A point Z0 is said to be an interior point of is said to be an interior point of the circle mod z minus a equal to r if replace z by z naught. So modulus of z naught minus a should be less than or equal to r. If this happens, I can say that z naught is a point which is nothing but interior point of the circle. So equality will come if it lies on the boundary of the circle. Less than symbol we use if it is strictly lying inside the circle. Okay. Now look at the example. Suppose I have a circle mod z minus 2 equal to 4. Suppose I am taking z naught equal to 3. Suppose I am taking z1 equal to, say for example, 5. Now in this case, modulus of 3 minus 2, it is less than 4. So replace z by z1, modulus of 5 minus 4, it is less than 4. Even I can take z2 equal to 6. Modulus of 6 minus 2, this is equal to 4. So in few occasions we are getting less than, in few occasions we are getting equal. So in this case, z1, z0, z1, z2, all these are interior points of this circle mod z minus 2 equal to 4. Suppose if less than or equal to is replaced by greater than, if less than or equal to is replaced by greater than, that point is called an exterior point. So here I am representing like this. If I write r here, so r is lying outside the circle. Sir, how to represent, sir? This less than or equal to should be replaced by greater than. That's it. So I am discussing that point, exterior point. Because when you are discussing contour integration, these are very, very important issues for me. A point z naught is said to be, a point z naught is said to be an exterior point of the circle mod z minus a equal to r if when you replace z by z naught, the modulus of total expression should dominate r. So modulus of z naught minus a should be greater than r. So earlier we took some examples. So what is the circle? I took mod z minus 2 equal to 4. Let me check out mod z minus 2 equal to 4, right? So in this case, suppose if I take z naught equal to, say for example, 7. Now here modulus of 7 minus 2 equal to 5. This is greater than 4. This is greater than 4. So therefore here z naught, see 7 is a point which is lying outside the circle. 7 is a point which is lying outside the circle. So in what way these are going to help us? When you are performing contour integration problems, you need to identify drawbacks of a function. Suppose you are trying to find integral f of z. Throughout the complex variables, I have a single task. I am telling you climax part also here. I am giving overview. I need to find integral f of z dz over c. I should know what are the drawbacks of f of z. So it has a specific name. They will be called as singular points. They will be called as poles, etc., etc. So suppose if you are performing a contour integration, I should know the drawbacks of f of z. I should know something about contour, that is C, circle. So suppose if a function has say for example 2 drawbacks, I should know how many drawbacks belonging to that circle. If one drawback belongs to that circle, you need to consider that point. If 2 points belong to that circle, you need to consider those 2. If 2 points do not belong to that circle, you need not worry about that. My value becomes 0. So I will discuss contour integration on Friday as well as Saturday, students. Very, very important concept. If you attend today's class, tomorrow, day after tomorrow, and Saturday, continuously 4 days, you can crack complex variables even if it is a very complicated UGC question also. Forget about GATE, even if it is, because UGC is more standard than GATE, University Grants Commission examination. So even we will be in a strong position to solve UGC questions, engineering services, Hyderabad Central University entrance, ISRO questions like that. GATE is nothing in front of this. Okay. Now it is clear. So in this case, 7 is an exterior point. Right. Now let me have some general conversation. Suppose I have z equal to a plus ib. So what will be its complex conjugate, sir? A minus ib, z bar. So here I am going to add both these z plus z bar. ib gets cancelled. I will get 2a. So here A equal to average of Z and Z bar. So what is A, sir? Real part. So this A is real part of Z. So this is average of Z and Z bar. This is average of Z and Z bar. Hope it is clear. Next, I will try to find out. So I will try to apply minus between these two. Z minus Z bar. So what you will get, sir? 2IB. Imaginary part will come. So B becomes Z minus Z bar whole divided by 2I. What is B, sir? Imaginary part. So imaginary part is Z minus Z bar whole divided by 2I. It is Z minus Z bar whole divided by 2I. Imaginary part is Z minus Z bar whole divided by 2I. Right. Now let us have one important concept. Suppose I have e power I alpha exponential. So this is nothing but cos alpha plus I sin alpha. E power I alpha is nothing but cos alpha plus I sin alpha. Sir, in what way this is going to help us? Yes, I'm coming to that point. Let me tell you one simple example. Suppose evaluate I power I. This is very, very important, students. This problem have been asked many times since last 25 years. Many times it was asked I power I. Now I am taking this form. I am writing this one e power I pi by 2. So to replace this I, so therefore this becomes cos pi by 2 plus I sin pi by 2. Cos 90 is 0, sin 90 is 1. So I becomes e power I pi by 2. So therefore the value of I power I is the base I am replacing by e power I pi by 2. The power I am writing as it is. So e power I pi by 2 whole power I. This becomes e power I square pi by 2. I square is minus 1. Now you will get e power minus pi by 2. So therefore this is very, very important, students. Remember this. I power I is e power minus pi by 2. I power I is e power minus pi by 2. It was asked many times. Right. Now what we did, sir, I am going to generalize this. Because every time they may not ask the same question. They may change the strategies in 2022 or 21 or in the future years ahead. So here basically this is a power of complex number. This is power of a complex number. So therefore when you try to find the power of a complex number, say for example z power k, let me write out this. See, I need to find out z power k. So k can be any real number. This is my general problem. Very interesting, very, very important. Z power k. So sometimes k can be fraction also. K can be negative values. K can be positive integers. Suppose they may ask, suppose z power 20. So if they just simply I am saying if they ask a larger power, some trick will be there. So z power 20. How can you evaluate normal evaluation? How can you do this? If you do not have this formula, how people will follow? So normal evaluation, I am writing simple procedure. Students, attention please. Normal evaluation. So Z can be written as Z star, and so on star. So how many stars will be there between consecutive Z's? 19 stars. So 19 stars are there. So 19 multiplication is required. 19 multiplication. Good morning, solid fighter. Yes, very good. Your work has been started. So today's basic class, but I am covering all the points little bit fast, but I am writing all the points. Don't worry. So today, tomorrow, day after tomorrow, and Saturday, complex variables will be finished within just 4 hours with a very beautiful questions. Simple questions I leave to you as an exercise. Okay. Good morning, solid fighter. Very, very good morning. Right. So 19 multiplications are required. So if you, this is normal lengthy calculation. This is a blunder procedure. So we are not supposed to do this. But it's one simple way, if you want to perform normal multiplication, so people can do like this. So first of all, I will calculate z square. Z square equal to z star z, single multiplication. Now z power 4 I evaluate, I don't go for z cube. So I will write z square star z square. Next I will go for z power 8. So I can write it as z power 4 star z power 4. I can go for z power 16. This is z power 8 into z power 18. Now I z power 8. Now I want z power 20. So you can write it as z power 16 into z power 4. Or you can write it as z power 4 times z power 16. Now, sir, what is the magic in this? How many multiplications? What we achieved by these evaluations? So this is one evaluation. So whatever the z square I got in this, I am replacing z square here. So apply star, I am getting z power 4. All these are powers of 2. Now next, once I get z power 4 in the second iteration, I am trying to get directly z power 8, not z power 7 or z power 6, using z power 4 star, z power 4. Now how many stars are there? Here it is 1. Here it is 1 star. Here it is 1. Here it is 1. So finally it becomes 1 here. So totally 5 multiplications are required to evaluate z power 20 in the more smartest way. If you do not know complex variables technique, this is best. But still I can do like this. So my task is this, sir, z power k. So if z equal to e power I alpha, if z equal to e power I alpha, for some alpha belongs to real numbers. Here R means set of real numbers. Here R is set of real numbers. So if this happens, then my job is very simple, sir. So then z power k becomes this base z value I am replacing by e power I alpha whole power k. So this becomes e power I alpha k. This becomes e power I beta, where here beta is alpha k. You will get some number. Now this is in the form e power I beta. So I can do like this, cos beta times I sin beta, like this. This is very important result, students. So very common model in the examination is asking power of a complex variable. So if they ask what is z power k, z will be given, k will be given. You try to identify real part and imaginary part of z. If they are flexible to replace it by e power I alpha, your job becomes very simple. Sometimes some manipulations are required. Sometimes some manipulations are required. So do some manipulations, you can easily understand. Do some manipulations, you can easily understand. Is it clear, students? Right. Now I am going to tell you one simple thing. Once it is complete, once it gets completed, I will go to differentiability, continuous functions and Cauchy-Riemann equations. I can close within 20 minutes also, don't worry. Suppose I need to find 1 plus I whole power 8. I need to find out this. What is 1 plus I whole power 8? This was, chemical engineering 2016 gate question. This was chemical engineering 2016 gate question. 1 plus I whole power 8. So how to do this, sir? Very simple. One way is like this. 1 plus I, you write it as 1 plus I whole square whole power 8. Apply a plus b whole square formula. You will get 1 plus I square plus 2I whole power 8. I square is minus 1. So they will be nullified. So you will get 2I whole power 8. So this is what is, so this is 4, right? This is 4. Yeah, let me write it more clearly. This is power 4. Already I wrote square. So therefore this becomes 2I whole power 4. So this is 16 I power 4. So I square is minus 1. I power 4 is plus 1. So it is 16. Exactly, Satvik. No, it is 16. It is 16, Satvik. 2 power 4 is 16, right? 1 plus I whole power 8. 8 I express as power 2 whole power 4. I applied a plus b whole square formula. I square and minus plus 1 get cancelled. So 2I whole power 4. You will get 16, right? Sir, can you do this using previous formula? Can we use e power I alpha? Yes, why not? Look at this. Z power 8 I need to find. Here what is Z sir? 1 plus I. So what I will do is I can write Z equal to square root of 2 into I multiply with root 2 divide with root 2. So 1 by root 2 plus 1 by root 2 I along with this root 2. So therefore this is square root of 2. This is what sir? Cos pi by 4 cos 45 degrees plus I sin 45 degrees. So therefore this is square root of 2 into e power I pi by 4. So therefore in this case Z power 8 is root 2 whole power I power 4 whole power 8. So root 2 means 2 power 1 by 2, 2 power 4 16. So this becomes e power I 2 pi. Cos 2 pi plus I sin 2 pi. Cos 360 is 1, sin 360 is 0. So you will get 16. This is one way. Yes, this is De Moivre's theorem only. Satvik, this is De Moivre's theorem only. This result is, this is De Moivre's theorem. This is De Moivre's theorem only. Okay. This result e power I alpha equal to cos alpha plus I sin alpha. That is a De Moivre's theorem statement. Right. Now look at, suppose I have a complex valued function f of z. All of your attention please. I have a complex valued function f of z. Say for example, I take it as e power z. E power z. So what is z sir? X plus iy. So e power x plus iy. So e power x into e power iy. E power x into, I will tell you the conclusion, just wait for a few minutes. E power x into cos y plus I sin y. So this is e power x cos y plus e power x into sin y. Now I can call it as u of x comma y plus I into v of x comma y. So here what is u sir? E power x into cos y. V is e power x into sin y. So here what is my conclusion from this example is, you take any complex valued function f of z that can be expressed as u of x comma y plus I into v of x comma y. Sometimes u may be purely function of x. It may be purely function of y. It may contain both x and y. Sometimes u may be constant. So my conclusion is every complex valued function f of z can be expressed as u of x comma y plus I into v of x comma y. U is nothing but a real part of f of z. V is imaginary part of f of z. And those two functions play very, very important role in the analysis of Cauchy-Riemann equations by using the concept of differentiation as well as continuous functions, right? So therefore, here I am writing note. Attention please students. Every complex valued function f of z can be expressed as f of z equal to u of x comma y plus v into I into v of x comma y. Every complex valued function f of z can be expressed as f of z equal to u of x comma y plus I into v of x comma y. Now it is clear, right? Now let me discuss the concept of continuous function. Very important students. Already we have seen the concept of continuous function in the differential calculus. So I will tell you in a very simple manner. Just within 2 minutes it will be over. I have a complex valued function f of z. I need to analyze its continuity at a complex number z, z0. So we say that f of z is continuous at the point z0 if the limit of a function at that point exists, and that should be equal to functional value. The same definition we had in case of differential calculus. So let me write out this. A function f of z is said to be continuous at a point z0, is said to be continuous at a point z0 if limit z tends to z naught, f of z exists and it is equal to f of z naught, and this is equal to f of z naught. So limit of that complex valued function f of z must be finite number at that point z naught, and that finite number should be equal to functional value. This is not a new definition. We have seen in differential calculus. Now there are real variables and these are complex variables. Sir, is there any difference between real variables and complex variables? Definitely. So those points we will discuss in the climax part. Now what are the examples? We will discuss some note. What are the basic examples of continuous functions in the real plane? We have seen e power x in the real variable, because if differential calculus part is very clear, 75% of complex variables is very, very clear. All the properties, all the theoretical part, what we have seen in case of differential calculus, that is in case of real variables, they will be again extended to complex variables. Remaining 25% properties will be additional to complex variables. So those are not part of real variables, and you can expect very extraordinary gate questions from the rest of the 25% concepts. Okay, so we have seen exponential function, sine function, cos function, and even constant functions. So these are continuous at all points in the real plane. The same strategy will work out here also. The function e power z, sine z, cos z, polynomial, constant function, all these are continuous in the entire complex plane. So I am writing this point, e power z, comma sine z, comma cos z, comma all polynomials and constant functions. And constant functions are continuous at all points, all continuous at all points in the entire complex plane, are continuous at all points in the entire complex plane. Next we go for differentiability concept. Now once it is over, I will go through analytic functions, very, very important concept, and then Cauchy-Riemann equations. Analytic functions and Cauchy-Riemann equations. What is your doubt, Satvik? Check limit. Limit z tends to z naught, f of z. You need to find limit of this function f of z at the point z naught, and that should be equal to functional value f of z naught. Right, differentiability. See, differentiability also we can expect or we can discuss in terms of limit of a function. Okay, now I am writing this. All these we have seen in differential calculus, so I am writing this point directly. A function f of z is said to be differentiable. Is said to be differentiable if limit h tends to 0, f of z plus h minus f of z divided by h exists. What is the meaning of exists, sir? It is a finite number. Exists means it is a finite number. No, it is not required here. Satvik, it is not required. There is no concept of left-hand derivative, no concept of right-hand derivative in complex variables. No need to worry. In this case, you need not worry. But here, in the form of Cauchy-Riemann equations, we need to verify. So, in case of complex variables, in place of real variables, there is a discussion about evaluation of left-hand derivative, right-hand derivative, left-hand limit, right-hand limit, etc. But in this case, particularly focus on differentiation, because once the differentiability concept is over, the same differentiability will be extended to analytic function. Analytic function. Once analytic function is clear, I will talk about Cauchy-Riemann equations. That is very, very, very important. Of course, if you understand Cauchy-Riemann equations, you can handle any question. So throughout if you ask me, sir, what is the most important concept to understand total complex variables? My answer is unique. That is analytic functions. That's it. So whenever limit h tends to 0, f of z plus h minus f of z by h exists, it is called a differentiability. And in this case, f dash of z is denoted by this expression, that is limit h tends to 0, f of z plus h minus f of z whole divided by h. This is a derivative of a function. Okay. Now let us take one simple example. Suppose I am taking f of z equal to z bar. I need to find derivative of this. Very important, students, attention please. F of z equal to z bar. If there is no bar, it's a polynomial. So what is the derivative of z with respect to z1? But here it is z bar is there. So write the definition. F dash of z equal to limit h tends to 0, f of z plus h minus f of z divided by h. So therefore this is limit h tends to 0. This f of z plus h is z plus h whole bar minus z bar divided by h. So this is limit h tends to 0. I can go for linear property of complex conjugate. So this plus z bar and minus z bar get cancelled. So what I will get, sir? In this case, I will get f dash of z equal to like this. Limit h tends to 0, h bar whole divided by h. Yes, how much, sir, it is? Limit h tends to 0, h bar divided by h. How much it is? Limit h tends to 0, h bar divided by h. Can anybody guess? When you replace h by 0, 0 bar is 0. So 0 by 0 will come. So immediately, the concept of L-Hospital rule will come into your mind. But again, if you try to apply L-Hospital rule, again the derivative of h bar becomes h bar by h only. So the form will continue. So therefore, f of z is not differentiable. This f of z is not differentiable because this is not a finite expression. This is not a finite expression. Hope it is clear. Exactly. Indeterminate. Exactly. So therefore f of z is not differentiable. Even I can discuss this example once I complete Cauchy-Riemann equations. Okay. Right. Attention please, students. Next I am going to discuss analytic function. Very, very important. This is the key point to discuss Cauchy-Riemann equations. This is the key factor to analyze Cauchy-Riemann equations. Suppose I have a complex valued function f of z. I have a complex valued function f of z. I have some complex number z0. So we say that f of z is analytic at that point z0 if f of z is differentiable at all points in some neighborhood of z0. You know the neighborhood. Neighborhood will be measured always using open intervals. So how a neighborhood of z0 looks like? The neighborhood of z0 looks like this. Open interval z0 minus epsilon, comma z0 plus epsilon. This is nothing but epsilon neighborhood of z0. This is nothing but epsilon neighborhood of z0, where epsilon is a number which is greater than 0. So this is when you change frequently epsilon values, you can produce infinitely many neighborhoods. So I am repeating once again. Attention please. A function f of z is said to be analytic at a point z0 if f of z is differentiable at all points in some neighborhood of z0. One neighborhood will be sufficient because when you change epsilon values, for z0 you can produce infinitely many neighborhoods. So multiple neighborhoods are not required for me. One neighborhood will be sufficient for me. If in that neighborhood, if f of z has a differentiation at all points, I can say that f of z is a analytic at that point. So I am writing this point. Attention please, students. A function f of z is said to be analytic. A function f of z is said to be analytic if f of z is differentiable if f of z is differentiable at all points in some neighborhood of z0. If f of z is differentiable at all points in some neighborhood of z0. In some neighborhood of z0. Now neighborhood of z0 will be in this form. Open interval z0 minus epsilon comma z0 plus epsilon, where epsilon is greater than 0. Now could anybody say examples of analytic functions? Could anybody say examples of analytic functions? You take at any point. All polynomials have differentiation at all points. Sine function is differentiable at all points. Cos is differentiable at all points. E power z is differentiable at all points. Therefore, I can say that this one, simple notation I can use like this. All polynomials, comma, constant functions, comma, e power z, comma, sin z and cos z are differentiable or analytic at all points in the entire complex plane, or analytic at all points in the entire complex plane. Okay, so such functions we call them as entire functions. So here I am writing such functions are called entire functions. This is also one of the useful definitions, students. Such functions are called as entire functions. So if f of z is analytic at all points in the entire complex plane, such functions are called entire functions. What are the best examples? Polynomials, constant functions, exponential, sin z, cos z, etc. If we have a function, not a combination of functions other than this, then you need to verify analytical properties in a precaution manner. Otherwise, you will face many difficulties. Okay, right. Now I am discussing Cauchy-Riemann equations. Attention, students. CR equations. So this is Cauchy-Riemann equations. Right. Exactly, Satvik. Suppose I have a complex valued function f of z. I have a complex valued function f of z. So how I can represent this, sir? U plus iv, u of x comma y plus v into f of v into I into v. Suppose I am taking z0 equal to x0 plus iy0. So I can write this point as x0 comma y0. So it means that if a complex valued function f of z is analytic at this point, we all know that analytic implies differentiable. See, analytic properties at a single point leads to differentiable properties at infinitely many points. Because if you take every neighborhood of z0, take any neighborhood of z0, it is in the form open interval z0 minus epsilon comma z0 plus epsilon, and such neighborhood always contains z0. So if I say that f of z is analytic at a point z0, ultimately I can say that f of z is differentiable at z0. So now in f of z, basically there are two functions. One is u, another is v. But u is a function of x and y. V is a function of x and y. It may contain both x and y. So in that case, derivative exists means I need to discuss a partial derivatives of u. I need to discuss a partial derivatives of u with respect to x and y. I need to discuss a partial derivatives of v with respect to y. Of course, first order partial derivatives. And I should establish a relation between those first order partial derivatives. Such equations are called as Cauchy-Riemann equations. Cauchy and Riemann, they are very, very famous mathematicians. The famous mathematician Cauchy have invented one equation. Riemann have invented one equation. So combinedly, I call them as Cauchy-Riemann equations. Look at this point, students. If f of z equal to u of x comma y plus I into v of x comma y is analytic, at z naught equal to is analytic at z naught equal to x naught plus I y naught. So this I can represent it as a pointwise notation, x naught y naught. Then all first order partial derivatives of all first order partial derivatives of u comma v exist at z naught and they satisfy the following equations. And they satisfy the following equations. Let us see what those equations. So the first equation is ux equal to vy. The second equation is uy equal to minus vx. These should be satisfied at z naught, and these equations are called as Cauchy-Riemann equations. So the first equation is invented by Cauchy, second was invented by Riemann. So what is ux's are here? Ux is dou u by dou x, uy dou u by dou y, vx dou v by dou x, first order partial derivatives, vy dou v by dou y. So you need to remember these two equations. So analytic implies differentiable, but f of z is differentiable means whatever the functions contributing f of z, they should be differentiable. What are the key functions in building f of z? U and v. So therefore u may contain both x and y, v may contain both x and y. So I need to talk about partial derivatives. So ux equal to vy and uy equal to minus vx at this point. So therefore such equations are called as Cauchy-Riemann equations. Such equations are called as Cauchy-Riemann equations. Hope it is clear, students. Hope these points are very, very clear. These equations are called as Cauchy-Riemann equations. So I am going to previous slide. So I have a function f of z, that is u of x comma y plus I into v of x comma y. Assume that this is analytic at this point z naught. So z naught is a complex number, that is x naught plus I y naught. This is rough part. Now this I can represent it as a pointwise notation x naught y naught. So if this function is analytic at this point, ultimately it is differentiable at this point. So I can talk about first order partial derivatives of u and v. So I wrote the same point. If f of z is equal to this function, which is analytic at the point z naught, then all first order partial derivatives of u comma v exist at this point, and they satisfy the following equations: ux equal to vy, uy equal to minus vx at z naught. These are called CR equations. So ux, uy, vx, vy, they are simplified. They are written more clearly: dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Hope it is very clear, students. Very good. Very good. Okay. So I leave you within a few minutes. So tomorrow, you never miss tomorrow's class. That will be extension of Cauchy-Riemann equations followed by residues and poles. Very, very, very important. So tomorrow's class and today's class, if you understand this, Friday class, Saturday will be so flexible. You can handle any extraordinary tough question also. Now this is batch, evolve batch for GATE 2022. ECE batch A have been started by best educators of ECE. The same equivalent batch is handling by electrical best faculty members of the country, that is evolve for GATE 2022. Hurry up, students, take subscription today itself. Use my referral code GVK10. So my referral code is GVK10 to take subscription. So this is official Creatrix channel which contains more than 10,000 members. Remember, students, Creatrix is part of Unacademy only. So of course this is upgraded to English channel. So this is Telegram channel of our channel Unacademy GATE English, where you can get links of free live classes like free YouTube class, free special classes, free quizzes, free test series notes in PDF format. Once the class gets completed, we are sharing notes in PDF format. Are you getting PDF format? Students, are you getting PDF notes in this Telegram channel? Please let me know. Are you accessing this? Now, these are India's #1 study channels running by Unacademy. Currently we are in this channel, Unacademy GATE English. There is a channel Creatrix Grade Electrical, Electronics and Instrumentation, Unacademy GATE Mechanical, Production, Engineering Science, Unacademy Civil, Chemical, Computer Science. They are exclusively maintaining one channel for GATE questions. Very great initiative from Unacademy side. And there is a channel, exclusive channel for Electrical Junction. All right. Thank you guys. Thank you. See you tomorrow. Thanks a lot.